All right, so today is Monday. What's the date? The 27th. I'd like to talk to you about the plan for the next couple weeks. This next chapter, half of it we've already done. So you'll see you have two sections tonight. I'm going to blow through just a refresher. There shouldn't be a lot of notes because you've done this before. We're talking about domain and range. What is a function? We're quickly reviewing this. Okay, so 12.1 and 2 is every other odd. We're going to be doing 12.3, again, another review. It's really like function notation. You're writing simple linear equations in function notation. And then given something to do, like given an input once you write the rule. Wednesday, we're going to take the Chapter 11 test. I'm not doing much review other than what we go through on the homework today, because that between that and the other review should be enough to review it. Thursday, we are doing 12.4, which is graphing quadratics. This is the first new section. That can be quite complex. Friday, there's going to be no school. Monday, we do 12.5 and 6. They're new information, but they work well. I've always taught them together because it's direct variation and indirect variation. So you'll do half your problems will be one way and the other you'll do the other way. They're opposites. And it's a short test. And because half of this chapter is review, I'm not going to be giving a quiz for chapter 12. Are you clear with me? So then we'll have a day of review, and then we'll have the chapter 12 test. And then that Thursday will be open house. I will not be here as I'm going on a school trip. Okay? And that Friday I will not be here. I'll be here on that Thursday during class time, but not at night. Both of those are half days, and that's why I'm rushing all this in so we can take this test before you go on spring break. Now, spring break, I am going to give you a practice SBAC test. It'll probably be like 30 or 40 problems, but it should be fairly easy. It shouldn't take more than an hour and a half of your spring break time. That means it will be like, for 7th graders, you will be doing a Math 7 practice SBAC test. For 8th graders, you will be doing a Math 8 practice test. Does that make sense? Okay, so that is our schedule. It's pretty compact, all right? All right, I just reviewed the quiz, and now we're going to be reviewing 12.1 and 12.2, which are sections that we already have covered and you've already been tested on. So we're going to go through this very quickly. It's not going to be the kind of stuff where you're taking notes on. I'm just refreshing your memory, okay? So remember we talked about what is a function. It's like an input-output machine. Did you guys remember all that? Yeah. Okay. We create input-output tables. Can you two please stop talking? Okay, we're creating input-output tables. And when I substitute x into the equation, we get an output. Does that make sense? So when x is 2, y is 10. When x is 3, y is 15. So you guys remember that. Yeah. Now, a relation are sets of ordered pairs. They're sets of ordered pairs. The domain is the input or the x's in those ordered pairs. Do you guys remember all of that? Yeah. The range is our output. Quickly. So what would be our domain here for this relation? This is a relation. What is the domain? Yes?
2 through 5.
Really? Is that how I write a domain? Absolutely not. It is not a 2 through 5.
2 is less than x.
No. One more time. Who knows what the domain is? These are specifics. This is not conceptually of everyone. There are specific situations. Yes?
X is such that X is...
No. Yes,
The domain is 2, 3, 4, 5, and
that's it. 2, 3, 4, 5. They are specifics. Okay? There's no variable there for it to be multiple answers. You guys are giving me answers for multiple possibilities. There's no variable there. It's specific. Do you guys understand that? So what would the range be, Keenan? Where did I get the domain? Greg, where'd you get that?
the X.
Those are the X's in all the pairs. Where do we find the range? Yes. Okay, so what is the range?
5, 7, 9, and 11.
Good. Marcus, domain and range for the next one.
The domain is -3, -2, -1, and 1. And
Good, stop. Somebody else, range. Scott,
10, 10 and 6.
just 10 and 6, and we don't write the repeats. Remember that? So this is all review from like chapter 3 of Big Ideas. We talked about some easy word problems where our domain, and this is when I taught you to identify your unknown. Do you remember that? I said, don't just give me an X, tell me what it represents. Give me a definition for it. So that's when I was teaching you that X, we write the definition. Y, we write the definition. The X is our domain, the Y is our range. And then once we wrote the rule, I gave you an input to substitute in. Do you remember that? So we're substituting in. Given the rule, what happens when you have 20 barbecues? 20 barbecues we called X. It's an input. We input 20. Okay, so we did this. We did some looking at X and Y charts and looking at mapping. Remember, we could take our X and Y chart and put it into this kind of mapping where you list all the possible X's once, all the possible Y's. And what 2 arrow -4 means, that's an ordered pair. Do you guys remember that? That really represents 2 -4, 1 -2. And we get that from our table. This is called mapping. This is called XY chart, a table. We can tell whether they are functions from the map. Remember, we talked about a function is a type of relation where none of the x's repeat. Do you remember that? Yes? No? Is there anything new here? Should be easy homework tonight. Notice you're doing every other odd. So it's not even half of 30. Between 15, 20 problems. I mean, actually, I should probably just give you the odds. But, because some of those are lengthy. Some of those are lengthy, they're a pain in the butt. You know, what given the domain is X, what is your, what is the f of X? Remember that? So, is this a function?
No.
That is.
When I substitute in, I'm having some controversy here. Shh. Remember I never list any repeats in the map. Why is it a function?
It's not a function.
Why is it not a function?
Because there's a repeat and there's like no y for that last step.
Well, 1 is 6, 2 is 7, and 3 is 7.
3 can't be 7.
Caitlin?
Well, I guess because, if you were to apply number type, 1 plus 5 equals 6, but 3 plus 4 equals 7, not 3 equals 5.
No. Not, yes.
Because none of the x's repeat.
None of the x's repeat, so that means it's what?
It's a function.
It is a function. It is a function. All of you guys are looking at the y's repeating. Absolutely, you can have y's repeat. There's no addition here. There's no addition. It had nothing to do with addition. These are ordered pairs. It is a function because this passes the vertical line test once I put those points on the graph. It is a function because there are no repeated x's. That is the rule for a function. For every output, there's exactly one input. Is this a function?
No.
Why? Now, where is my arrow going to go for 1? To the 6. And to the 7. Okay, can somebody stop humming, please? Thank you. Okay, so it's not a function. You guys with me? X's can't repeat. Oops, is this a function?
Yeah.
Because the x's do not repeat. Is this a function?
Yeah.
Because the x's do not repeat. Is this a function?
No.
Because the x's repeat. Okay? Now, they might give you an equation and ask you to determine if it's a function. You can make a table. You should be able to make a table. So whatever is happening that's changing, that is your input. Right? So notice the x will be changing. So when I substitute that in, you can see that there is no repeated x's. Look at the other one.
Second one.
If I put it into mapping form, we can see there's no 2 lines that come out of the inputs. If you look at the next one, which values am I choosing here for the x equals absolute y? This time I choose the y because that's what's changing. That's different. And so when I take the absolute value, I get 2. When I take the absolute value of -1, I get 1. And then if we mapped it, it would look like this. On the graph, it would be like a sideways V, right? All right, is this a function?
Yeah.
Is this a function?
No.
Is this a function? Is this a function?
No.
Who's saying yes? Okay, we gave you some simple rules. Remember how to write the equation. This is all linear stuff, very easy. How do we get the m? How do I figure out my slope? The change in y over the change in x. So this difference is 4. This difference is 1. So -4 over -1 makes 4. So y equals 4x. And notice my y-intercept is +0. What about here? What do you think this one is? Y equals x plus 5 because it's 1 over 1 and my y-intercept is that 0, 5. Remember we did what is your x-intercept, what is your y-intercept? To find the x-intercept we set y equal to 0. To find the y-intercept we set x equal to 0. So in that case when x is 0 there's my y-intercept. What would the next one be? Good, or 1/2 x, good. And then the last one, what's my change here? -3 over -1 is, so it's going to be y equals plus that 2. You guys remembering that? Remember function notation. It's fancy way to write. Fancy way to write. So we're just saying, this is really the x given. When x is 1, 2 times 1 plus 3. Do you remember that? When x is 2, 2 times 2 is 4 plus 3 is 7. That's how we get that. They might give us something like this, the g of x. So it tells me when the x is 4, 2 times 4 is 8. Do you remember how we write that? And then when I have the h function, 4 times -2 is -8 plus 1 is -7. The h of -2 is -7. You guys remembering this?
Mm-hmm.
Then they get more complicated, like stuff like this. So here we're going to find the result of -5. It's -15, -17. Right? And g is -2 squared is 4. -17 plus 4 is what? -13. No, it's times, sorry, -68. This one, we always start inside, order of operations. The h of 3 is what? 7. Right? And then I take that 7 result and I plug it in here, substitute it in, and it's 49. Do you guys remembering that? Okay. The one thing I want you to remember, when you're doing this, make sure that I generally don't like you to write your answers like this because you can get yourself in trouble. Because if you rearrange them and write 0, 8, -4, you lose 3 points. So what this implies is that the f of -1 is -4. So I really kind of prefer you to write the f of -1 is -4. The f of 0 is, the f of 0 is 0. And then the f of 8 is, the f of 2 is 8. Does that make sense? Because this is referring to a specific domain. It's specific. You can't just put them from least to greatest. And since the first one was this, it's referring to the first one is here. The second one is referring to the second one, the third one. But kids, if they rearrange those, you'll lose 3 points. So the best way to write it is like this. Are you guys clear on that? Okay. Oh my gosh, hold on, really quickly. Shh. Domain and range, vertical line test. Just remembering what a vertical line is. Do you guys all remember this? Yeah. What is a function? So we're just reviewing that. Shh. More of the same. What is a function? The domain. We're mixing it all up. Do you remember this? This is similar to what we just did. I mixed it up for you on Friday. The only thing that's different is, let's look at this one right here. These two sites. This one, it's an element of the reals, and what else?
Oh, x cannot.
Or s is greater than or equal to 0.
Okay, it's a combination of both. It can't be 0 because it's a fraction, and it can't be negative. So how would I write that?
S is greater than 0.
Greater than 0. Shh. This one, pretty much, it can't be, it's an element of the reals, and it can't be 4. What about this one? Okay, now the other one is when you see stuff like this, a graph. This we did with Desmos. Guys, this we did with Desmos. So if I'm talking about my domain, that's the width, the x. How wide can it go? It can go on and on forever with this. So we say any real number for the domain. But the range is the height. Greater than or negative or equal to. You guys remembering that? Okay? And same thing here. My domain, if it's a parabola, it can go on and on forever. So it's an element of the reals, but the range, it has to be greater than or equal to -5. It will never be, my y's will never be -6, -7. Is that clear? All right.